In this project, our team chose 3 real-life examples of right triangles that appear in our daily lives. Then, we calculated the height of a tall object just by measuring the object's shadow and a volunteer's shadow and height. Now, we will display the definition of the concept of similar triangles.
Similar to the thriller in Manila. Honeys call me bigger, the condom filler. Whether it's stiff tongue or
I represented a right triangle using the right corner of the vertex soccer field. The formula that I used was only the Pythagorean theorem, the Hyperion formula, using the opposite and adjacent, because that were the sides I got from the measurements I measured of the soccer field, and the angles were the same because the sides were the same, so it was a 45, 90 degree angle.
In this triangle, as you can see, we're just missing the hypotenuse and 2 angles. To get the hypotenuse, you can use the Pythagorean theorem, with which you can get the hypotenuse, and with that use sine, cosine or tangent to get the corresponding angles for those sides.
In this triangle, we're just missing the hypotenuse and the 2 angles. To get the hypotenuse, I used the Pythagorean theorem, in which is c squared equals a squared plus b squared. Now, when I got the hypotenuse by using this theorem, I used sine and its inverse to get the angles and of the 2 other sides.
To get the height of the object, we first measure its shadow, and the height and shadow length of a volunteer. With this information, we got the angle of elevation of the sun, which is corresponding in both triangles considering they are similar triangles. With the angle of elevation and the shadow of the object, we use tangent to get the height of the object.
Okay, in this project we learned many things. For example, we learned that right triangles are in our everyday life. And we also learned that by using the Pythagorean theorem and sin, cos, and tan, we can get the obtuse and hypotenuse and adjacent of these angles, which are in our everyday life.